Okay, in this video we're going to take a look at the code to add a node to a binary tree. Now there are two situations that we can consider. One of the situations is when the root pointer is null. So when the root pointer is null, that means we do not have any node in the binary tree, right? So whatever new node we have, let's say there was this was Dublin, right? So this was the new node that was stolen from the free list, right? And the new node pointer is pointing towards this node, and it has a data value of Dublin. So if root pointer is null, that means there is no node in our tree, which means what? Which means this is going to be the first node in our tree. So the root pointer must point to this node, right? So the root pointer, in case if root pointer is null, then root pointer must point to this node towards which the new node pointer is pointing at. So this is one of the situations that we are going to consider when we are going to add a node to the binary tree. And the second situation is when we already have some nodes in our binary tree, and this is the new node that is going to be added. We've stolen this node, and we're going to add this new node to our binary tree, and the value that is to be added is Lahore, right? I just realized when I showed you this example here, when the root pointer was null, right, this node should also have two pointers, right? So the right pointer and the left pointer, right? So I made a mistake early on. This is what a node in binary tree looks like. So coming back, this is the node, this is the value that we're trying to insert, right? And the way to do that is we start here, we position TNP at the root node, at the starting node, and we set the value of and once we've done that, this becomes our current node. We compare Lahore with Dublin. Because Lahore is greater than Dublin, we are going to update TNP using the right pointer, right? So but before we update TNP, just we did like we did in linked list, right? We are going to use a second pointer. Remember, I told you whenever you have to add a node, whether it is the linked list or whether it is the binary tree, you're going to have to use two pointers, right? So before we move TNP, before we update its value using the right pointer, we set PNP equal to TNP. So PNP is now pointing to this node, and we also do one more thing. We use a Boolean variable called turned right. We just named our Boolean variable called turned right, and because we're taking a jump towards the right, we set its value to true. We set its value to true, and then so we first made PNP point towards this node before TNP is updated, and we've also set the value of turned right equals to true to note down that TNP is going right. Okay, so then we update TNP. Once these two actions have been taken, then we update TNP, and TNP now comes to the next node. So once TNP comes to this node, at this stage PNP is at the previous node, and we also have this Boolean variable which is telling us that the last jump was taken in the right direction because turned right was set to true at this point. Okay, so now at this in this situation, this node becomes the current node, and we compare Lahore with the current with London, right? And Lahore is less than London, so this time we'll have to update TNP. We will have to move TNP. We'll have to update it using the left pointer, right? But before we update TNP, we are going to make PNP equals to TNP, and this time we are going to set the value of turned right equals false, because we are not taking a turn towards right, rather we are taking a turn towards left. So when turned right is false, that means we are going left. So once we have done, we've taken these two actions. Once we've done this, then we can update TNP. So TNP is updated, and TNP is updated using this value, right? The value lying in the left pointer. So TNP is going to become null. So TNP will become what? Null. Once TNP becomes null, we have to stop updating TNP. So we don't have to move any further, and at this point in time we have found our insertion point, right? Because TNP has become null, right? We can see that PNP was PNP is still pointing to London, right? So we are at the last node that TNP was at. We are one step behind TNP, right? And we also know that TNP became null. When TNP became null, we took a jump in the left direction. So these two parameters are very important. We know the node that TNP was at before it became null, and now we also know the direction in which the jump was taken by TNP. It went left, right? So this concept is very critical. And one more thing we should understand, when we have nodes inside of our binary tree, and for example if we were to add this value Athens, right, we will keep updating TNP, right, and following this process of PNP and turn right equals to true or false, right, until we reach a leaf node, right, until TNP becomes null. Because this node Athens is also going to be inserted with a leaf node, and a leaf node is one which has one of its pointers or both of its pointers set to null, right? So in this case, Athens is less than Dublin, so we are going to come here, and Athens is less than Berlin, and we are going to go this way left. When TNP goes left, it becomes equals to null, right? So once TNP becomes equals to null, we know that we've reached our point of insertion, because at this stage PNP is going to be pointing here, and our turned right variable, right, is going to be equal to false because we went left, right? So we take these actions, right? Remember, every time TNP is updated, before it gets updated, we set the value of PNP equals TNP, and then we set the value of turned right to true or false depending on the direction in which TNP took the jump. Okay, so what we've done here is I've written my procedure. I've called that procedure insert node, right, and I'm passing it one parameter, and that parameter is data item. So this is the value that's going to be added, and then I am stealing the node from the free list. Once again, if you don't know how this piece of code works, how stealing a node from the free list works, take a look at my video on queues, right? How to add a node to a queue, right? If you take a look at my video on how to add a node to a queue, you'll find that I've explained this piece of code in great detail, right? So when we have to steal a node from a free list, whether it is for a queue or it is for a linked list or it is for a tree, it's done the same way. The only difference perhaps is that the name of our array in this case is tree, because all the nodes are lying inside an array, and we have chosen tree as the name of the array, right? And what we do is we set the data value of our new node equals to the parameter that has been passed, and the left pointer of our new node is set to null, and the right pointer of our new node is set to null, which makes sense obviously, because this is a new node, and when a new node is connected to a binary tree, it is always connected to the bottom of the binary tree, and this node does not have any nodes below it, right? So the left pointer is going to be null and the right pointer is going to be null. Now once we have stolen a node from the free list, what we should know is that this node has been set to something like this, and here we have a value such as Dublin, right, and the new node pointer is pointing towards this node. So so far what we've done is we've stolen a node from the free list, and next we are checking if the root pointer is null, because if the root pointer is null, right, then this new node, it becomes the first node of our tree, right, and that is what we are doing here. We first check if the root pointer is null. If the root pointer is null, then we make the root pointer point to the same place where the new node pointer is pointing at. But what if the root pointer is not null? If the root pointer is not null, then we already have some nodes in the binary tree, right, and in that case, you know, we're going to start by positioning our TNP at the root node, and then we'll keep moving TNP down until we find that point, you know, where we have to add our node, right. We have to find the point of insertion, and for that, you know, we are also going to be using PNP, and I've already discussed this, and we're also going to be using a variable, a boolean variable called turned right, right. So TNP will keep updating until TNP becomes null, right. For example, if we were to add Athens, you know, we'd eventually TNP would become null when TNP moves left from Berlin, right. When it moves left from Berlin, that is the point that TNP becomes null, right. So we keep updating TNP till it becomes null, and let's write code for that. So quickly, what we've done is that if the root pointer is not null, then we come to this else clause, and here what we've done is we've done our declarations. We've declared TNP, we've declared PNP, we've declared turned right as a boolean variable, and finally we have positioned our TNP to point towards the root node, right. We've set TNP to point towards the same node that root pointer is pointing at. Okay, and now what we've done is we've set up a loop, a while loop, which will keep running as long as TNP does not become null. Inside of this loop, we are going to update TNP so that TNP can move from one node to another node to another node until it becomes null. Once TNP becomes null, this loop is going to stop. So the first thing that we are going to do before we update TNP is that we make PNP point to the same node that TNP is pointing at. So once we've set PNP equals to TNP, now we can update TNP. We can update TNP and we can move it to the next node. But remember, in a binary tree, there are two options, right? TNP can go right as well as TNP can go left. So we can either go right or we can go left, right, depending on the value that we're trying to add. So for example, if we were trying to add Athens, right, then Athens is less than Dublin, that means we are going to go left, right. But if we were trying to add for example Lahore, then you know Lahore is greater than Dublin, so we would go right. So we have to take a decision whether we have to use the left pointer to update TNP or we have to use the right pointer to update TNP. What we've done so far is we've set PNP to point to the same node that TNP is pointing at, and now we want to update TNP, and that is exactly what we are doing here. What we are doing is we are comparing the data value that we want to add with the data value of our current node, right. The current node is the node that TNP is pointing at. So in our array tree, the node towards which TNP is pointing at, that node's data value is compared with the value that is going to be added, right. So if the value that is the new value that is going to be added, if that is greater than the value of our current node, then we are going to go right. And if we are going to go right, then we are going to update TNP using the right pointer of the current node, right, using the right pointer of the current node. But before we update TNP, we must also note down, well, it doesn't matter if we do it before TNP is updated or after TNP is updated, but within here we should also note down the direction in which the jump was taken, right. So because TNP was updated using the right pointer, we've set turned right equals to true. Okay, but if that's not the case, if the data value that is being added, the new data value, if it is less than the current node, right, if it is less than the current node, if it is less than the data value of the current node, then we come to the else part, which means what? We are going left now. If we are going left, we are going to set the value of turned right equals false, and we are going to update TNP using the left pointer of the current node. Okay, so let's go through this piece of code once again. Each time the loop runs, we set the value of PNP equals to TNP. Then we decide whether we have to update TNP using the right pointer or using the left pointer. We do that by comparing the value that is going to be added with the data value of the current node. And once we do this comparison, if we have to go right, then we update TNP using the right pointer, and we also set turned right equals to true. If that's not the case, we go to the else part. This means that we are taking a jump to the left, so we set turned right equals to false, and we update the value of TNP using the left pointer of our current node. So this keeps happening, this loop keeps running, and this keeps happening. All of this action keeps happening until the value of TNP becomes null. When the value of TNP becomes null, now we have found our insertion point. Remember, once, for example, let me go back up, let me show you this tree. If we were trying to add Lahore, finally we would compare Lahore with Dublin, right? We know that Lahore is greater than Dublin, so we are going to go right. But before we go right, we set PNP to point towards this node, and we set the value of turned right. I'm just going to write it down as TR. We are going to set it to true, and then we're going to go this way, right? We're going to update TNP, and once we've updated TNP, this becomes our current node, right? We compare Lahore with London. Lahore is less than London, which means we are going to go left, right? But before we move TNP to the left using this left pointer, we set PNP to point here, so PNP will no longer be pointing here, PNP, and we also update the value of turned right. Because we are going left, that means turned right is going to be equal to false, right? And once we've taken these two actions, then TNP is updated using the left pointer of this node, and which means what? TNP is going to become null. So once TNP becomes null, we know when this TNP became null, our PNP was pointing, it was a step behind, and it was pointing at the node that TNP was previously at before TNP took this jump. And when so PNP was at the node from where TNP took the jump, so PNP was at that last node, and also we have the value of turned right, the final value of turned right before TNP took the jump, right? And we know that TR was set to false. So in this case, in case of Lahore, it is critical to use this value of PNP and the value of turned right to now decide that this is the node, the node towards which PNP is pointing at, this is the node to which we want to add our new node. And we take a look at turned right, and we see that its value is false, which tells us that the last jump was taken in the left direction. So we know that it is the left pointer to which our new node Lahore is going to be added, right? So we use both of these informations. We use PNP and we use the value of TR, turned right, I should not say TR, right? We should use the value of turned right to determine which node and which pointer of that node. So this is the node which PNP is pointing at, and the left pointer of that node, because TR equals false, turned right equals false, right? And that is where we add a new node. So let's go back and let's write that piece of code, right? So once this loop stops, we are now ready to finally link our new node to our binary tree. Okay, and this code is fairly simple, right? If turn right equals true, that means we have to now add uh, we are now going to use the right pointer of the node that PNP is pointing at. We're going to update the right pointer of this node, and we're going to make it point to the node that new node pointer is pointing at, right? So if turn right is true, we are going to update the right pointer of the node that PNP is pointing at. But if turn right equals false, then we come to the else clause, and this time the node that PNP is pointing at, that node's left pointer is going to that node's left pointer is now going to be set to point towards the same node that new node pointer is pointing at. So this is how we are going to link our new node to the binary tree. Okay, so what if the examiner asks us to write a recursive procedure to find the insertion point in the binary tree? Remember what we did just now, we found our insertion point using an iterative method, right? We used a while loop. Now to write our procedure, recursive procedure, let's declare it first. And you know what I've done here is I have named my procedure find insertion point, and I am passing it 4 parameters: TNP, PNP, turn right, and data item. Now you should remember the reason why we are writing a recursive procedure is that within this procedure we are going to keep updating TNP, and before we update TNP, we are also going to update PNP and turn right. So these are the three variables that we'll keep updating, and we'll keep calling this function recursively. We'll keep calling this procedure recursively until the value of TNP becomes null, because once the value of TNP becomes null, that is the time when we have found our point of insertion, right? So we'll keep calling the recursive procedures until the value of TNP becomes null. So inside of our procedure, the first thing that we are checking is whether the value of TNP is not equal to null, because if the value of TNP is not equal to null, that means we now need to move TNP, right? TNP has to be updated. It now needs to be moved to a new node. So if TNP is not equal to null, that means what we are doing is we are setting the value of PNP equals to TNP, because TNP is about to be updated. Before TNP gets updated, we make PNP point to the same node that TNP is pointing at. So once we've set the value of PNP equals TNP, now we can update TNP. But remember, this is a binary tree. In a binary tree, we have to make a decision whether TNP is going to be updated using the right pointer of the current node, or if TNP is going to be updated using the left pointer of the current node. And this is exactly what we are doing here. We are checking if the value to be added, if it is greater than the current node, right, the node towards which TNP is pointing. If the value that we're trying to add is greater than the data value of the current node, then we are going to turn right. Therefore we set turn right equals true, and then we update TNP using the right pointer of the current node. However, if this condition is not true, then we go to the else part, right? In this case, we are going to go left. Therefore what do? We set the value of turn right equals false, and now we update TNP using the left pointer of the current node, right? So this else part is executed when the data value that we are searching for is less than the data value of the current node. So if the data value that we are searching for if the data value that we are going to add, I should be saying if the data value that we are going to add is less than the data value of the current node, then this gets executed. That means we are going to turn left, so we set the value of turned right equals to false, and we update TNP using the current node and using the left pointer of the current node. And once we have updated TNP, we've also updated turned right, and we've also updated PNP. Now we are ready to place our recursive calls. See, we are once again going to call this procedure, but this time we are going to pass the updated value of TNP, the updated value of PNP, and the updated value of turned right, so that we've now moved on to the next node, and we will examine the next node to once again make a decision whether TNP has to go right or left. So what I've done here is, and I should have written the word call here, right? And let me just, okay, so we are now placing a call to our function find insertion point, right? This is a recursive call, and we are passing the updated value of TNP, PNP, turned right, and we are also passing the value of data item, the value that is going to be added to our binary tree. So once again, let's quickly take a look at what this code is doing. Every time this procedure find insertion point is called, we make sure that the value of TNP is not equal to null. If the value of TNP is not equal to null, that means that we have to update the value of TNP. So first what we do is we make PNP equals to TNP, and then we update TNP, right? So that way PNP stays a step behind TNP. Alright, once we have made PNP equals to TNP, then we decide whether we have to go right or left based on the data value of the current node and the data value that is going to be added to our binary tree. We compare these and decide whether we have to go right or left. So if we have to go right, then we set the value of turned right equals true, and we update TNP using the right pointer. But if we have to go left, then this part of the code gets executed. The value of turned right is set to false, and the value of TNP is updated using the current node and the left pointer of the current node. Okay, and now that we've updated all the items, we've updated PNP, we've updated TNP, we've updated turned right, we place a call to our function procedure find insertion point, and we pass the updated values of TNP, PNP, and turned right to our procedure. Now this keeps happening until the value of TNP becomes null. So until the value of TNP becomes null, these recursive calls keep getting placed, and each time we are inside the procedure, we check if TNP is not equal to null, we update the value of PNP, we update the value of turned right, we update the value of TNP, right? So we do all of these steps, and once again we call our recursive procedure. So this keeps happening until the value of TNP becomes null, and when the value of TNP becomes null, that is our point of insertion. So once TNP has become null, we found our point of insertion. We don't need to update TNP anymore, because we don't need to update TNP anymore. We don't need to place recursive calls anymore. So once TNP becomes equals to null, we have our insertion point, right? And now what we can do is we can modify this code on the left here, right? And we are going to, rather than this iterative solution, we are going to replace it with a recursive solution. We are going to find our insertion point recursively by calling the recursive procedure. So let me update this code.